All right, we're in section 3.4, exploratory data analysis. And the thing that we want to look at here is the 5-number summary and box plots. So first off, 5-number summary. So this is basically kind of the 5 numbers that summarize a data set. And those 5 numbers are, the first one that we list is the lowest data value, or the minimum. The second number that we choose is Q1. That's the 25th quartile, or percentile, 25th percentile, or the first quartile. Then the next number we're going to choose is Q2, which is also the median, or the 50th percentile, or the second quartile. And then the fourth number is Q3, the 75th percentile, or the third quartile. And then the last number we want is the highest data value, or the maximum. Okay, so we're going to look at a data set. We're going to look at a couple, and we're going to create the 5-number summary. And then once we have the 5-number summary, we're going to create a graphical representation of this by doing a box and whiskers plot. Okay, so here's our first example. We have the numbers 147, 243, 156, 543, and 303. All right, so let's look at these data. The first thing that we want to do is put them in order, smallest to largest. Okay, so if we do that, it's 147, 156, 243, 303, and 543 are our numbers. So how many data points do we have? 1, 2, 3, 4, 5. So n is equal to 5 in this. So the first thing I want to do that we saw before, if we're going to find Q1, Q2, Q3, the first one we find is Q2. So we're going to find Q2, knock off the first and last, and then the next first and last. So Q2 is that middle number, 243. Q1 will be the median of this lower data set, but there's only 2 values in that lower data set, so we're going to add them up and divide by 2. So that's 147 plus 156 and divided by 2, we get 151.5. Now the next thing we need is Q3. And Q3 is the median of this upper data set. And again, there's only 2. So we're going to add them up and divide by 2. So 303 plus 543 divided by, whoops, can't quite do it that way. You got to put it in parentheses if you're going to divide by 2 all at once. Divided by 2 is 423. Okay, so those are our Q1, Q2, Q3. Let's talk about our max and our min. So our minimum value is 147, and our maximum value is 543. And we should probably look at if we have any outliers. So let's do outliers. So remember, we need the inner quartile range, which is going to be the Q3, 423, minus the Q1, 151.5. And we get 271.5. All right, now that we have our inner quartile range, we have to multiply it by 1.5 to find the amount that we subtract off of Q1 and add on to Q3. So now we're going to go 1.5 times our inner quartile range. So that's going to be 1.5 times 271.5. So that's 407.25. Okay. So now we want to look for the lower limit. That's Q1, which is 151.5 minus that inner quartile range times 1.5. And notice this is giving us a negative number. And that's okay. So that's negative 255.75. And now we're going to do the same thing for the upper limit. We're going to take the upper limit is Q3, which is 423, and add on that 407.25. And that gives us 830.25. Now we look at our data. Is there anything below negative 255.75? Nope. Is there anything above 830.25? And the answer is no, so there's no outliers. All right, so we've got all the information to draw our box and whiskers plot. Let me move this thing. Okay, so box and whiskers. Whoops. All right, so the first thing that you need for a box and whiskers plot is a horizontal number line that spans your data set. So if we look at our data set that we have, the smallest number is 147 and the biggest number is 543. I need to have a data set that will cover all of those values. So let's start our count at 100, and let's go 150, 200, 250, 300, 350, 400, 450, 500, 550, 600 should do it. All right, so that covers our whole data set. All right, and now what we want to do is the minimum value gets a dot above it, that line. So 147. So 150, 147, kind of move it kind of high up. So there's our 147. And the maximum value, let me just grab this data so that we're not scrolling all over the place. Okay. Our maximum value also gets a point. So 543, that's someplace in here. So we're gonna, whoops, 543, we're gonna put a dot up here. I don't know what's going on. Don't want all that. Oh, I see what is going on. Okay. Sorry, guys. There we go. 543. Now, Q1, that's 151.5. That's going to get a vertical line. So right by 150, it's got a vertical line at it. And Q3's got a vertical line. That's 423. So 450, 423, somewhere right in here. And then we're going to connect those two vertical lines and make a box. That's the box. And then the last vertical line we have is Q2, 243. It gets a vertical line inside that box. And then we connect the dots to that box. Those are the whiskers. So a lot of times I'll label my values because otherwise it's really hard to see. Whoops. Of course I should label them correctly. So this is 423 was Q3, 151.5 was Q1, and 243. And then the last one was the maximum, which is 543. All right, and that's our box and whiskers. And it kind of tells us, basically, the interquartile range tells us where 75% of the data is. Interquartile range is equivalent to 75% of the data, or no, 50% of the data, where 50% of the data is because it's between the 75th and the 25th quartile. So that's where 50% of the data lies. And then the rest lie outside of those quartiles. We have the maximum value, the minimum value, so we have our full spread of our data. Now there are, if we look at this, let's grab this again and look at what it says. It's talking about the information obtained from a box and whisker set. So if we look at this, it says if the median is near the center, which ours isn't, of the box, the distribution is approximately symmetric. If the median falls to the left of the center of the box, the distribution is positively skewed because we have a longer tail over here. If the median falls to the right, then it's negatively skewed. There's also, if the lines are about the same length, that means these tail lines, then it's symmetric. If the line, if the right line is larger than the left line, then it's positively skewed. If the left line is larger than the right line, then it's negatively skewed. So it's kind of like talking about the tail, where all the data lies in terms of where the median is. So over here, this one is positively skewed. Now, sometimes these will contradict each other a little bit. And so I always go with the tail lines. If the tail line is longer on the right, it's positively skewed. If the tail line is longer on the left, it's negatively skewed. If they look approximately the same, I tend to say that it's symmetric. I just have to pick something, so that's what I pick. All right. We're going to come back and do a couple more examples of this. One case with one data set, and then another case where we have two data sets on the same axes.